Hey, it's Coach Reeves. Here we're with an introduction to log equations. So we're going to take this in small steps. As we go through the week, the rigor will start going up. But these are just another step up from converting what you did yesterday. Okay? So if you have this log equation, okay, we're going to convert this to an exponential form so we can actually solve this equation. Remember what we said, your base is going to stay the base, but we're going to switch who you're paired with. So in this case, my base is 11. So your base will stay your base. And instead of being paired with the b, we're going to pair it with the -1. Okay? But we can't leave a negative exponent in our problem or in our answer. So remember what a negative exponent told you to do? This said we're going to push it to the bottom of the fraction. So when I push this down, this is going to go to the denominator, and this is going to be 1 over 11 to a positive 1 when you push it down across the fraction bar. Okay? Now the 1 is optional. We probably won't ever write that 1 there, but this is what your answer is going to be. This is going to be to the 1 over the 11. Okay? I told you it's just going to be another step up from converting like we did yesterday. Okay, let's look at another problem. Okay, a little bit more. We want to get the log portion. We want to get the log portion by itself. This is what we would like to get by itself. So we're going to move some stuff, and then we're going to convert it to an exponential form. Okay, so what I would like for you to do is we're going to add 6. You're going to say log base 5 of x plus 10 equals, when you add 6, you're going to get a -1. All right, so now on this problem, we're getting ready. We've got the log portion by itself, so we're going to convert this to exponential form. My base will stay a base. This is going to be 5. But it's now, instead of paired with the parentheses, we're going to be pairing it with the -1. So this is going to be 5 to the -1 equals x plus 10. In this case, negative exponent, we're going to push it to the bottom. This is going to turn into 1/5 equals x plus 10. Okay, and then you're going to say -10 minus 10, that's a 5, excuse me, and you're going to say 1/5 minus 10, we're going to make that over 1, equals to x. I need to get a common denominator. So we're going to multiply the bottom times 5, we're going to multiply the top times 5, and that will give me 1/5 minus 50 over 5, and that's going to equal a -49 over 5 equals x. So what are we trying to do? We're trying to get the log portion by itself, and then we're going to convert it to exponential form, and then solve that equation. Let's try another example. We want to get the log portion by itself. So we're going to move the 6 to the other side. We're going to say plus 6 plus 6. That's going to give me log v plus 3 equals 2. Now we got it by itself. Now we need to convert it to exponential form. Do you remember what we said yesterday? That if the log didn't have a base, if it didn't have a base down here designated with a certain number, that it was going to be an understood base 10. So if they don't tell you what the base is, it's understood that it's going to be a base 10. So when we convert this, we're going to say 10, your base stays your base. We're not going to be paired with the v plus 3, but we're going to be paired with a 2. So that's 10 to the second equals v plus 3. And we know that 10 times 10 is 100 equals V plus 3. We subtract 3, we subtract 3, we get 97 equals V. There's my answer. Okay? All right, let's try a couple more. Okay? But before we get any further, okay, we're going to get these equations. Okay? This is going to be kind of similar to, remember when we did same base? If we could get our exponents to the same base all the way around, then we could just set up an equation with their exponents only. Okay? So in this case, everybody's going to have the same base. So if you have log base of 11 of an expression, log base 11 of an expression, things will just set up an equation with the things that are in the parentheses, those two expressions. So we could just set up an equation and say 7 minus m equals negative 2m minus 9. It's that simple. They both have log base 11, so we can just set up this equation. In this case, I would ask you to go plus 2m, and that would equal m. We would move the 7 to the other side. We would say minus 7, m equals a negative 16. That may be a good answer, but you have to be careful because now there's two rules, okay? Here's the first rule. You cannot take the log of a negative number. It's a no solution situation, okay? You cannot take the log of a negative. Can't do it. Cannot take the log of a negative. Can't do it. We also cannot take the log of 0. If you try to take the log of 0, it's going to be undefined, okay? So you cannot take the log of a negative number. We can write a number here. And we also cannot take the log of 0. It's going to be undefined. But we're going to substitute negative 16 in our parentheses to see if it works, okay? Excuse me. Negative and a negative will give you a positive, so that's going to give you a positive 23, so that's okay. If we substitute negative 16 here, negative 2 times negative 16 is 32. 32 minus 9 is 23. This checks out. But if this would have totaled a negative number, if you just said the log base 11 of, say, negative 4, then I would have to kill that because you cannot take the log of a negative number. So whatever number you substitute in, you would have to cancel that number out, okay? But in this case, we said m equals 16. We substituted in to check for an extraneous solution, and we said it was good, so we could keep it. All right, let's try another one. All right, in this situation, log base 2, we can set up an equation. We can say that x squared minus 62 equals 4x minus 2. Just like the previous problem, they both had the same log base, so it just, everything had that, so we could just drop it out and set up an equation. This is squared, this is a quadratic, so I would ask you to move it to everything to the other side, and we would say minus 4x, we would say plus 2, and plus 2, and that would give us x squared minus 4x, and a negative 60 plus 2, or negative 62 plus 2 is a negative 60. Okay? You okay with what we're doing? So we're going to factor this. This says the signs are going to be different, okay? And it says the bigger number gets that sign. So the signs are going to be different. And we're going to break down x squared as x times x. But my back number is 60. So it's a negative 60. Since it's a negative number, we're going to subtract to find our combinations. We're going to use, I can go 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, or 6 times 10. Which combination, there's a bunch of them, which combination subtracted will give us a 4? The 6 and the 10. But we said the bigger number gets to be negative, so that's going to be the 10 is going to go with the minus sign. The 6 is going to go with the plus sign. And when we solve this, this will give us a negative 6 as a solution, and this is going to give us a positive 10 for a solution. But we have to go back and substitute them in to check for an extraneous solution. So let's try negative 6, okay? 4 times negative 6 is a negative 24 minus 2. That will give me a total of negative 26. I cannot take the log of negative 26. It's going to tell me it's undefined. So that answer is not good. This is going to be an extraneous solution, so you don't include that number. Okay? Let's try what happens with the 10. So we're going to substitute the 10. Okay? So we're going to substitute a 10. 4 times 10 is 40. Minus 2 is 38. Okay, that's good. We're going to come over here and we're going to say 10. 10 squared is 100. Minus 62 is 38. And that checks. So the number 10 would be the only good answer out of those two. It's possible for both answers to be good. It's possible for only one of the answers to be good. Or it could happen that both of them would be extraneous, and then we'd have to say no solution. Okay? So the bottom line is, let's go back to the beginning. I'm going to ask you to get what? We're going to ask you to get the log portion by itself and then convert this to an exponential form. Get the log portion by itself and then convert to an exponential form, and then you can solve the equation. Okay? And then the easier ones, maybe, for you, is if they both have the same log base, you can just set up an equation with the expressions. Okay? See what you can do on the worksheet. Practice. Let us know if you get stuck. Good luck.